everybody. It's the last lesson of Math 12, and it's short. We're going to do double angle identities, page 641. So in the last lesson, we went over all the addition and subtraction identities for sine, cosine, and tan, and hopefully you're okay with that. So we're going to use these to develop some new ones, the double angles. So if I have sine 2a, I can rewrite that as sine of a plus a. A plus a is 2a. Makes sense? We want to show that it is equal to 2 sine a cos a. So what we do is we use our sine addition identity, which is sine a cos b cos a sine b. So this will turn into sine of a cos of a plus cos of a sine of a. Well, these are the exact same thing. That turns into 2, you add them together, sine a cos a, which is our first double angle identity. And I'm going to summarize them on the previous page. We can do the same thing for cosine. So cos of 2a is a plus a, which is a cos addition identity, which is cos a b minus sine ab. So this turns into cos a cos a minus sine a sine a. Cos a times cos a is cos squared a, and same with sine. Same thing with sine squared a. Now this is the double angle identity right there. And then if you remember, we added these two onto it. So where do they come from? Well, if you take this one that we have, cos squared a minus sine squared a, and you remember that sine squared plus cos squared is equal to 1, I can sub out the cos squared. So cos squared, if I move the sine squared over, is 1 minus sine squared. So then I would get, instead of cos squared here, I'd get 1 minus sine squared a minus sine squared a that's already there, which gives me 1 minus 2 sine squared a. And that's this identity right there. To get the cosine one, you're going to sub out the sine by moving cosine over. You can do that on your own and see if you can get that question. There is a double angle for tan. We can do, we can do it. So tan 2a is tan a plus tan a, which using the tan addition identities is this, tan a plus tan b over 1 minus tan a tan b. So I get, let me erase that, tan a plus tan a over 1 minus tan a times tan a. That's straight out of the formula. Tan a plus tan a is 2 tan a, and tan a times tan a is tan squared a. All right, so, oops. Here they all are summarized at the top of this page. Okay, basically all these formulas do is they take an angle, we're calling it 2a, and they cut it in half. That's why they're called the double angle identities. 2a becomes a. In other words, for this one, sine of 90 is equal to 2 sine of 45 cos of 45. We cut the angle in half. Okay, that's what these do. So we can use them to prove too. So for example, 2 tan x over 1 plus tan squared x is equal to sine 2x. We want to show that that is true. Okay, so draw a line down the middle. We start with the more complex side. which is the left side. Remember, we don't want tans, so we want to get rid of all our tans. We write them as sines and cosines. So that's what this becomes. Remember, if you have a 1 plus a trig function squared, think of the Pythagorean identity. So 1 plus tan squared is secant squared. So that's over secant squared of x. What's secant? We don't want secants, we want sines and cosines. So f is the secant squared becomes 1 over cosine squared of x. Now we have a fraction over a fraction. You flip and multiply. Sine x over cos x times cos squared x. That cancels one of those and cancels one of those. And you're left with 2 sine x cos x. And if you don't recognize it, that's okay. Come over here, sine 2x is equal to 2 sine x cos x. That angle gets cut in half. And now you have left side equals right side, and you're done. Okay. Use the identity sine 2a is equal to 2 sine a, so the double angle identity for sine. With a replaced by 3x to determine a double identity for sine 6x. So what they're saying is, besides sine 6x, what does that equal? This is making it confusing. I want to rewrite sine 6x in another way. Well, that's a sine. All right. Sine 6x, what does a double angle identity do? It takes your angle and cuts it in half. 90 went to 45. So if our angle is 6x, it should become sine 3x cos 3x, and the formula has a 2 in front of it. So we put a 2, and that's it. You're done. Just like cos 10a. Double angle identity. It cuts the angle in half. Now, for cosine, you have 3 choices. Let's use the ones on the sheet. There, right there. You can take your angle, cut it in half, but it could be cos squared minus sine squared. So this could be cos squared 5a minus sine squared 5a. That gives you the right answer. Or it could be 2 cos squared a minus 1. 10a, so it gets cut in half. Or the final one, be 1 minus 2 sine squared of half the angle. Those are all correct. All right. The tan one, okay, there's only one. So as soon as you see tan, the angle gets cut in half, and it's 2 tan a over 1 minus tan squared a. So it's 2 tan, what's half of x? Well, it's x divided by 2 over 1 minus tan squared of x over 2. And that's it. So all they do is cut the angle in half. That is the key thing. Now we're going to go backwards. We're going to go from something that's expanded, and we're going to shrink it down. So if they have really looking stuff in here, what you can do is you can say theta is equal to 4. So about that. So this would become 2 sine theta cos theta. What does that look like? It looks like this. So when you go backwards, it becomes sine 2a. I'm going to erase all that. There's a lot of lines there. All right, so if we're going backwards, it becomes sine 2 of the angle. So if this is 2 sine theta cos theta, this will equal 2 sine 2, oh, not Sorry, this 2 goes away. There. Is equals sine 2 theta. And what was theta? It was 4x. So sine of 2 times 4x with sine of 8x. Okay? 8x is double what 4x is, or 4x is half of 8x. Same with this one. If you say theta is equal to 1/2 a, this turns into cos squared theta minus sine squared theta. Don't get confused. Cos squared minus sine squared is not 1. Cos squared plus sine squared is 1. Okay, so that's a big difference. But cos squared minus sine squared is a double angle identity for cosine. So it becomes cos 2 theta. What was theta? It's 1/2 a. So it's cos 2 times 1/2 a. 2 times 1/2 is 1, so it's just cos of a. Look, you don't have to do the substitution. If you see it right away, you can just realize it'll be double what that is. When you go backwards to simplify it, it's double the angle. If you're expanding it, you're cutting the angle in half. And the final one, 5/2 x. So we're going to do theta is equal to 5/2 x. So this becomes sine theta cos theta. Now, that looks like sine of an angle, cos of an angle, but we're missing the 2 there. Well, you can put the 2 in as long as you can't just put a 2 there. You put a 1/2 because a half times 2 is 1, and you can multiply anything by 1 without changing it. So now I'm going to put a bracket just so you can see. This bit is the double angle identity for sine. So it's sine 2 theta with the half out in front. This one right here. And what was theta? It's 5/2. So this becomes 1/2 sine 2 times 5/2 x. The 2's will cancel. And you get 1/2 sine 5x. And that, my friends, is the end of Math 12. Congratulations. The questions I would like to do is 2 to 5 and number 7, please. These just take practice. Good luck. Email me if you have any questions. Congratulations on finishing Math 12.